Hello, everyone. Welcome to an iOS Dev Mentoring session. In those sessions, we help students of the iOS Lead Essentials program to solve any technical challenge they're facing. And today, we are going to cover iOS 17 breaking changes in UIKit's UI refresh control.
That's it. Hello, everyone. Yeah, so this iOS 17 breaking change broke a lot of code bases and tests.
Yeah, we received many questions about it, so we decided to create a video to teach you how to deal with those changes and how to make it testable. So first, let's explain the problem with a sample project. We have here a very simple view controller where we set up the refresh control in view.load. So we create the refresh control, we assign it to the UI table view controller refresh control property. We add an action for when the user triggers a refresh by dragging the scroll view, the pull to refresh action. And we call refresh to start refreshing as soon as the view loads to get the data as soon as possible. So the refresh method will tell the refresh control to begin refreshing, which will show the animation on screen, and we'll refresh some data. Pretty simple setup. And before iOS 17, there was not a problem at all. It worked. We could update the refresh control state on view.load or view will appear or any lifecycle method. So to prove it, let's run it here on iOS 16. And as you can see, no problem. The view loads and the UI refresh control is refreshing. Now we also prepare some tests for this proof of concept where we just checking the state transitions. So we create our view controller. We tell it to call view.load by loading the view. And we check that the refresh control should be refreshing. And then we end refreshing and we tell the refresh control to send the actions for value changed, which simulate the pull to refresh action that our user would take. And that should trigger a new refresh. So it should be refreshing again. Pretty simple proof of concept tests. Let's run. On iOS 16, passing. No problem.
Yeah.
Look at that.
However,
This doesn't work anymore on iOS 17 and above. So let's run the app on iOS 17. Boom, look at that. So the view loaded, but the refresh control is not showing the animation, so it's not refreshing. And we also got a warning in the console that the UI refresh control received an off-screen begin refreshing and it was ignored, which means the test will also fail. Look at that, failed.
yeah, so the problem is that UI refresh control ignores calls to begin refreshing if it's not on screen. So even if we move the call to view will appear, it won't work because the view is not yet on screen. Let's run the app again.
That's it, same problem. We still get the console error and it's not refreshing. So it only works after the view is on screen. That's the breaking change. So for example, on view did appear. So view did appear is called after the view is on screen. Let's run. Look at that, no warnings, no errors. But the refresh control is not refreshing. Well, actually it is, but you need to scroll a little bit to see it. Now it renders. So from the user point of view, this may look like a glitch. Ideally, we want to change the state before the view appears, before it's fully rendered. So the UI renders in the right state. But how can we do it? View will appear is too early, and view did appear is too late.
So for that, Apple introduced a new lifecycle method on iOS 17, which is called view is appearing.
All right, let's try it out in the new lifecycle method. And it works. Look at that. That's it. Now it shows without any visual glitches.
That's it. The best thing is that view is appearing is backwards deployable all the way to iOS 13. So we can use it in any app supporting iOS 13 and above. It's pretty cool.
That's it. So we don't need to wait another 3-4 years to use this new method. We can use it right now.
Yeah.
Well, as long as you support iOS 13 and above.
Mhm.
And I think probably most apps are already iOS 13 and above. So that's great. That's how you can solve this problem. And I highly recommend you check the Vue is appearing docs. It explains exactly how this method works. So as you can see here, this method is called once each time the Vue controller view will appear. It's called after Vue will appear, but before Vue did appear. So it's in between these states. But the good thing is that when Vue is appearing is called, the Vue have received updated trait collections and the Vue has accurate geometry. So that's it. On iOS 17 Plus, we can move this call to Vue is appearing to start loading our data and update the refresh control. So it's all fine now in production. It works on iOS 17 and iOS 16, or all the way down to iOS 13. However, there are some problems to keep in mind. Problem number one, when we are testing a Vue controller with unit tests, we don't usually render the view on screen. Like we don't add it to the window and actually render it. Why? Because it's much faster and we don't generate any side effects by changing the current window hierarchy. But if the view is not on screen on iOS 17 Plus, the refresh control will ignore calls to begin refreshing. So let's have a look at our tests. First of all, we need to update our test because when the view is loaded, it's not refreshing yet. So our expectation is that after view did load, the refreshing control state should not be refreshing. And then we need to trigger view is appearing somehow to test what happens when view is appearing is called. Now we can simply call it directly and check that refreshing should now be true. However, calling view is appearing before calling view will appear or not calling view did appear after may leave the UI view controller in a weird state. Ideally, we want to run all the lifecycle methods in order to make sure that everything is set up correctly. So one way we can do it is to let UIKit call those methods by triggering transitions in our view controller when testing. We can call begin appearance transition. First parameter is appearing, yes, so we are testing when the view is appearing. Animated, false, we're not animating in our test. And this will call view will appear internally. And to finally call view is appearing, we need to end the appearance transition. So this method will call view is appearing plus view did appear. Just like we simulate calling view did load with loading the view if needed, we can simulate the view will appear and view is appearing and did appear by creating transitions.
Awesome. Yeah, let's run the tests.
And it fails. Look at that. The initial state on view did load is fine, it's false, but then triggering view is appearing is not enough because this view is not actually on screen. We are just running tests. We never added to the window hierarchy, for example. So the test fails, even though the production code is correct. It's working fine.
Yeah. So one solution is to add it to the screen by creating a UI window and setting the root view controller of the window to be our SUT. Of course, we need to make the window key invisible.
Okay, let's run the tests. And the last assertion is now passing, but the first one is not. That's because the UI is not rendered immediately. So we need to force it to load immediately. For example, we can tell it to layout if needed. Run the tests, and it's passing. Great. So by adding it to a window and making this window the key window, we are actually putting this view controller on screen and rendering the view. So this will call view will appear, view is appearing, and so on, all the lifecycle methods. It's actually rendering it on the simulator.
Exactly.
So we are forcing these lifecycle methods to be called, and this generates some warnings here, like unbalanced calls to begin and appearance transitions, which is not great because we don't know if this can generate issues in the future.
Yes.
So another way is to actually wait with a delay somehow to allow enough time for the UI to show on screen when it's added to the window. For example, you can tell the run loop to run until a given date, for example, 1 second in the future. All right, it passes without warnings. But because of the delay, it takes 1 second extra
Yeah,
per test.
that's way too slow. It's not acceptable. Because if we add many tests, it will be even slower. And we want those tests to run fast. Of course, we could try to lower the delay, like 0.3, for example.
Is that enough? Yeah, it seems like it.
Yeah, but the problem is that we cannot guarantee that the given delay is always enough.
Yes, it's dangerous to rely on delays and running things in the future because it may not be enough. So you have flaky tests. Sometimes it passes on your machine but fails on CI occasionally.
Yeah.
So we don't want to rely on delays. But it's not the only problem with this solution, because by making this window the key window in the running application in the simulator, we are globally affecting the host application. So this could even break unrelated tests that rely on the key window being something else.
Yeah.
You need to remember that when you finish the test, that you need to clear the window. Otherwise, you may lead some side effects after the test finished running. Remember, every test should start in a clean state and leave the system in a clean state. There shouldn't be any side effects in the system after a test finishes. But by altering the key window, we are altering state outside this test method. So it's dangerous. We are altering global state.
Yeah, another solution would be to write UI tests, but they're also very slow and flaky.
Exactly.
So ideally, we want this test to be fast, work without delays, without affecting the host app, as it did before iOS 17.
Exactly. We would like it to be like this, without changing any state outside this method, right?
That's
This
it.
is what we would expect it to be, like it was on iOS 16 and before. In fact, let's run this test on iOS 16. And it's passing. So it works just fine on iOS 16 without altering any global state. It's self-contained, it's fast, it's great. It's much simpler, much faster, and safer this way. But unfortunately, it doesn't work on iOS 17, so we need to deal with it. But there is a solution. Instead of using a real UI refresh control when running tests, we could use a fake test double, like a fake refresh control. This fake must be a UI refresh control, so we can subclass UI refresh control and override its behavior for testing purposes. And we could simply keep state in a boolean just to check if it's refreshing or not. Is refreshing starts at false. And we can also override the is refreshing getter to return our internal state. That's it. It's not a real UI refresh control. We are overriding its actual behavior. It's just a fake that works for testing purposes only.
Yeah, you should not use this in production.
So the solution is not as good as on iOS 16, but it works without delays or global side effects, so it's much safer. And that's the thing with testing. Sometimes we need to make some compromises here to make our tests fast and reliable. So let's use now this fake refresh control while testing. So right after we load the view, which is where the UI refresh control is created, we can replace refresh control with fake for iOS 17 support. And we can create an extension on our view controller and implement this method. And what we need to do here is to create our fake and replace our refresh control with the fake.
And we also need to move all target actions from the original control into the fake one to be able to test the actions.
Yes, that's it. We need to
Yes.
transfer those target actions set up to the fake. There are many ways to do it. One way is to iterate through all the existing targets, and for each action for that target. For which control event? Well, this is a UI refresh control, so we're interested in the value changed event. And we add to our fake. So we're transferring all the actions from the existing refresh control to the fake one.
That's it.
Now let's run this on iOS 16 to prove that it still works on iOS 16. Yes, all tests passing. Now let's run on iOS 15 and see if we fix the problem. And it passes. And it's super fast, and there are no warnings, no issues.
Fantastic.
Let's run the app on iOS 17 again, and it's working fine, no warnings as well. Fantastic. So problem 1 solved.
Mm-hmm.
We can make it testable with a fake. Let's check now problem 2. View is appearing may be called more than once. Remember, in the docs, it said that it's called each time the view appears. But view did load was called only once, only the first time the view controller view is loaded. So if you were using view did load and you want to keep that same behavior of running code only once, you need to ensure that you don't perform the same logic more than once here.
Yeah. So let's add an assertion to check this exact scenario.
To simulate this scenario, we end refreshing and we trigger the appearance transition again. So it's the second time the view is appearing. So this is simulating a new appearance of the same view. And we should expect now the refreshing status to be false if we want to only run this action first time the view appears.
That's it.
Let's run the tests. And it's failing because we are running the code over and over again every time the view appears. There are a bunch of ways to make sure that this is called only once. The most common and simplest one is to just keep state, some boolean.
Yeah.
We only call refresh if it has not appeared yet, if it's the first time, and then view appeared equals true. Run the test, and now it passes. So we prevent it from running more than once. If that's the behavior you want, every application is different. Maybe you want to run this every time the view appears. Who knows? We're just showing you if you want to keep the same behavior, if you have code in view did load, that's how you can do it. Now, there are other ways. For example, some people like to keep all the configuration in view did load.
Mm-hmm.
So for that, you could use a closure instead of a boolean. For example, on view is appearing. So every time view is appearing, you call this closure. So you can move the configuration, what happens on view is appearing, to the view did load. Example, vc.refresh. And if you want to run this only once, we set the on view is appearing to nil. So the next time view is appearing is called, there will be no closure set. Run the test, still passes. So it's up to you to decide. There are many ways to solve this problem, many solutions to run logic only once. For example, we could use combine. There are many ways to do it. Up to you to decide. So this solution works in production and is also testable.
We can also remove duplication and improve the tests with a helper. Simulate appearance is a good name.
We could trigger appearance transitions. And also, if it's the first time the view is appearing, so if the view is not loaded yet, we can load the view and call replace refresh control.
That's it.
Since we already covered the view did load in there, we can remove this. Look at this. Much more readable.
Absolutely.
So we create a view controller, we simulate the first appearance, we check the state. Then we simulate a pull to refresh action and see what happens. And then we end refreshing and simulate a new appearance to see what happens. As you can see, it still passes. Of course, you could also move this to a share extension to reuse this helper across many view controllers. It's up to you to decide how to organize your test. But again, make sure to only do it in the test target. This is for testing purposes only, never in production.
That's it.
And that's it for today. We hope this video helps you use and test UI refresh control on iOS 17 and above. Thank you for watching, and we see you again next time.
Bye, y'all.
See ya.